Can y'all hear me? This thing on? Good? Oh, there it is. Cool. So I am Paul Elliott. I work for Hashrocket. And I am going to talk to you today about integration testing. I'm going to talk about the tools and kind of the techniques that we use at Hashrocket. It's a big part of our life cycle. And the ecosystem for it is got some pretty awesome tools that have cropped up over the last 6 months or so. So I'm going to share a lot of that with you. So what integration testing means a lot of things. It's anytime really you're bringing multiple systems together, and it could be large or small scale, integration of 2 small modules or of your entire stack, which of course that is what it means when we're talking about it in a Rails context. When we refer to that, we're talking about driving the browser and testing the entire stack. And that includes a lot of things. Payment gateways, Google Maps, integration with Twitter, Facebook, gems, all of that. At Hashrocket, we typically have a huge integration testing layer. We don't do controller and view tests at all. We used to, and we found that the integration test suite, if it's very well written, just is a much more effective means of testing all of that. We have a pretty good sized model layer underneath that and helper tests as well. Now, integration testing, like much testing, is not really about bugs. Preventing bugs is a side effect of what you're doing, but ultimately it's giving you that chance to take a look at your system and think about what you're going to implement before you implement it based on the features you're doing. So one of the big things we get out of this is accountability for features. The integration testing layer is representing the contract with your client, right? So they give you the requirements, and the integration tests are the code embodiment of those requirements. It's also buying you maintainability in the future. You know right away when you break something that you didn't think was related. You make a change to a model, break some screen on the other side of your system, you may not have checked it. It'll pick up stuff like that. And because quality is important, we TDD everything, including our integration tests. And doing it in this way really improves the quality of our screens, of our controllers. And also, it's a narrative. It gives you a nice script that to think about how you're writing your tests, and it prints it out in the log, which is useful. You can show it to your clients if they're interested. Sometimes they are, in our experience. So you're wondering how we do it. We use Capybara, which is, if you're not familiar with it, it's an awesome gem from Jonas Nicholas of eLabs. It's an extremely flexible, powerful framework for driving a browser, essentially. And it provides a really cool DSL and swappable drivers under the covers, so you can use either a headless driver or a headed driver like Selenium, and it makes it really easy to do all of those different things. The DSL kind of looks like this. It's got all the links, or all the functions you would see in WebRat, and with some niceness. So you can visit like root path, or you can give it whatever you want. You can click links and buttons, and all that's based off the title of the button. If you really need to get crazy, you can say click_link or click_button, and still give it those titles, and it'll scope it to a button or a link. You can also give it an ID there. Typically, you shouldn't do that. If you're having to do that, probably done something wrong. But not necessarily. Sometimes it's a valid case. Filling in forms, super easy. As you can see, fill in name. So we're filling in a text field with a label name, value Paul. And the other thing about you doing that is you're verifying, of course, that the form label is tied to the input field correctly. Because if that for is not set up with the ID, then that's going to fail. Attaching files is really, really easy. You just give it the path to the file. You can see right in the example, I have a spec data directory. That's where we will put any of those kind of resources that are going to be used by the system. Checking and unchecking checkboxes, radio buttons, all easy to do. Assertions are really, really, really easy. So as you can see there, page should have content Paul. So we're just checking somewhere in the page, it has the content Paul. Only thing to keep in mind is that you're probably going to want to learn some XPath. You can use CSS selectors. I wouldn't unless they're very simple. Like in the case here, we're saying div with a class of personal info. You could do div.personalinfo, and it'll translate that fine. But under the covers, it's using XPath. And so if you have complex expressions, then it's probably not going to work out right. XPath will always work, though. So what it's doing there is saying within the personal info div, then it should have this other paragraph with a class of name and content text of Paul. You can do other things like give it a count. It's all very similar to the stuff you can do in WebWrap. So the great thing that Capybara buys you is all these different drivers. Out of the box, it gives you rack test, Selenium, Celerity, and Cularity. Typically, we use the rack test and Selenium drivers for almost everything. The rack test is headless. There's no JavaScript. It's pretty fast. And it's really, really good. And it covers almost all the tests you're going to do. You can run under rack test, unless there's heavy JavaScript, in which case you can run a Selenium driver, and it's really easy to swap it out. So I know a lot of people hear Selenium and cringe, but it's no different writing tests for Selenium than it is rack test. And there's external drivers, like Acapulus, which uses HTML unit and JRuby. There's MJS, which uses Rhino. And there's others. MJS was actually written by Stephen Parks, and he provided the patch to Capybara to allow for external drivers, which is pretty awesome. It really opened up the ecosystem. So if you want to write a driver for whatever your testing platform of choice is, you're open to do so. And I would definitely look at the MJS project because it's a really good example of how to do that. Another really important aspect, of course, is generating data. You can't really stub and mock because your server's running in a separate process, and those things don't carry over. So you have to generate data and persist it to the database for all your tests to work. So this is an example of the user fabricator. In this case, we're using a framework called Fabrication. It's kind of like Factory Girl or Machinist. It's got some syntax niceness. As you can see, there's no block yielded variables. And also, the most notable difference is that it doesn't generate active record associations unless they're accessed. So I'm going to show you in a minute, but you can create object graphs, and it won't write out the whole thing when you generate an object. So at the very base level, we have the user fabricator, and all that is the most basic data that we need to make a user that's valid in the system. So in this case, it's just an email, password confirmation. If you have special cases, like let's say you're doing email confirmations, then make another fabricator or factory with a different name, extend from user, and put whatever logic you need to do that in there. Or if you have roles, make additional fabricators and extend from those base ones so that you have a nice suite of ones to choose from. Designing your fabricators is really important because you're going to be using these all over the place. Also note the file name. All the frameworks like Machinist, Fabrication, and Factory Girl will let you have like a spec fabricators RB or spec factories RB. Don't do that. Just don't use it because that file is going to get gigantic and unmanageable really quick. If you break them out into the directory and then have explicit fabricators for the different kinds of objects you're making, it'll save you a lot of hassle down the road. So going one step deeper, we have a populated user, and we're going to be using the example of Twitter in the presentation here. I don't know what their data model looks like, so I kind of made all of this up. It's probably a lot more basic than what it actually looks like. But in this case, we are making a populated user with 40 tweets, 15 followees, and 15 followers. So you can see we're just generating a whole bunch of users and tweet objects inside of there. That count 40, or in count 15, that's part of that syntax niceness I was talking about. So what that'll do is just generate 40 tweets in that instance. Also, having a robust set of generators like this is important because you can also use these in your development seeds, so your development database and your staging database, potentially. We very commonly do that. So here's the rest of the fabricators. You can see they're all in separate files. There's the follow fabricator and tweet fabricator. Now the follow fabricators you can see has follower bang and followee bang. That's telling fabrication to generate those associations immediately. and skip the whole lazy generation thing. It's really important for things like a join table, where it doesn't make any sense to have it without those dependent objects. Also, random data is your friend. Can be very dangerous too. But putting random data in your generators is good because, for one, like if, let's say I generate a user, in most of my tests, I really don't care who that user is. I don't care what the email is or anything. All I care is that he exists. And having like a random generated email will not only document the type of data that's supposed to go in there, but it'll more or less guarantee the uniqueness of the data. Also, it's an indicator to somebody else who's looking at it later that the actual value of that is not really important, unless you're overriding it, in which case it is. Now, in all the examples I'm going to show, we're going to use RSpec. At Hashrocket, we use RSpec on some projects and Cucumber on some projects. It all depends on the team that starts out on it. I think for these examples, RSpec is more illustrative, so we don't have to go dig through step definitions or anything. Everything's just right there. RSpec, if you're familiar with RSpec 2, it's got, RSpec Rails 2 has a request example group, which is kind of like the integration example group of old, except it integrates WebRat. WebRat's all well and good, but we don't use that at Hashrocket anymore. So we use Capybara on all the projects, whether it's a Cucumber or RSpec. And so the RSpec integration gem, all it does is give you the integration example group, ties Capybara into that, and it depends on RSpec Rails. So you get all the stuff from that as well. So let's look at a real story. For Twitter, this is just a basic sign-in story that I kind of made up. So to have personalized experience on Twitter as a guest on the front page, I want to sign into my account. And then we've got our acceptance criteria down at the bottom. So there's a sign-in button, and clicking it shows the email and password fields. Valid credentials take the user to his feed, and invalid credentials show the error screen. Those screens look something like this. You click sign in, and there's some JavaScript that makes that form appear. If the form is invalid, you get to this bottom left one here with the error message, and if it works, then you go to the other one with your home screen. I'm sure you all use Twitter, know how that works. So the spec would start out looking something like this, and the reason that we've got the Selenium driver specified in there is because of that JavaScript pop-up. If we were using rec tests, of course, that wouldn't show up. But you can see how easy it is to swap the drivers out. That's all you got to do. So now we've got the outer describe for a guest signs in, and that's matching the feature name. And then you can see the file name matches the outer describe, and that's really good, a good philosophy to have, because when you're looking at it in the log, it's going to say whatever that outer describe is. And if it matches your file name, it just makes it really easy to go and find that later on, especially when your test suite gets huge. And then you can see the nested context. So as a guest on the front page, and with valid credentials, it takes me to my feed. With invalid credentials, it's all same stuff as the acceptance criteria. And we're really writing out that narrative here. Same thing you would do in Cucumber with your story, except here we're doing it with pended tests. So when you run it, you get something like this, that narrative I keep talking about. And it should all be very readable. You should be able to read it as a sentence going all the way down, which more or less you can do in this instance. So the actual implementation is going to look something like this. We're using before all and after all in all these examples, so that we only have to do this setup once, and we can run a whole bunch of examples against the screen, because otherwise you're going to be browsing to the same screen, a dozen times, and that's going to kill the performance of your suite. So we're generating the user. That first line there is telling RSpec to generate the user. If you haven't used let before, it's awesome, and you should learn exactly how it works. Basically memoizes the response and gives you access to it later on, so you don't have to use add variables. And then we're calling tweets there just because fabrication won't generate them without. Then we're browsing through the site just like a regular user would. We're going to, start at the root path. We're going to click that sign in button. We're going to fill in username or email. Of course, I'm referencing by the label. And we're putting in explicit values there. And it's really important to put explicit values in the data that you're generating, because you're going to assert against them later. And you want to be, like I said before, random data indicates that it's not that important. And when you put those explicit values in, you're saying that I expect that it is definitely going to be this. And we had an issue recently because we're working on it. We have an app called Squadron, and it's for a kind of team management. And in Squadron, you can make projects. Well, I was working with a dev, and we started writing this test, and we created this project called Squadron inside of Squadron, and we're asserting against it. And then I was like, wait a minute, the text Squadron's all over the place in this app. We can't use that in the example. So something to think about whenever you're writing those and you're putting that explicit data in there, make sure you're not using terms or text that's going to be on the screen, because that can come back and bite you. So at the end there, of course, we're doing the after all sign out. You may or may not have to do that depending on how you set your tests up. Oh, one other thing. So I said click sign in, and then I said click button sign in. And the reason for that is when the page first loads, all there is that one sign in button. The pop-up's not visible yet, and Capybara only looks at things that are visible on the screen. So it's okay to do the more ambiguous click there, because it's only going to find that one. And then we have to do the explicit click button, because the first one is a link, the second one's a button, so it's going to scope it to an actual button tag. And here's the rest of the test. So we have our context all filled out now. With valid credentials, then it takes me to my feed. With invalid credentials, we have another before all here. We're going to go back to the root path, click sign in. We're just not going to fill anything in, and we're going to submit the form. And then you need to put some specs or some examples in there that verify that you got to that error page and displays the message. Now, that error message is something that would only be on that page, so you don't need to scope it to anything. Just checking for the text on the page is totally fine. That middle one, where it takes me to the real sign-in page, I noticed that Twitter has this convention of putting an ID and a class on there for the controller and the action. So that's something that you can assert against. You can assert against paths. The best thing to do is if there's some kind of text or something that uniquely identifies the page that you can assert against, something that the user would see is always the best way to do it. I just wanted to illustrate that you could do it in other ways. All right, so now that we got our sign-in spec, we want to abstract that out, because you're going to do that all over the place. And all your specs, you're going to go and say, sign in the user. And this is a typical sign in as function that you would see in one of our test suites. So we're aliasing it to sign in, because most of the time we don't care who the user is. So we're just going to say sign in, and it's going to go through the steps and actually sign the user in through the screens. And then sign in as we would use if we're going to pass the user in. You can see it's defaulting to just a regular fabricated user. All right, so let's try an image upload. So here's another story I made up that falls in line with Twitter's website. In order to personalize my account, user on the profile settings page, I want to update my profile picture. And the acceptance criteria is that the profile picture displays on the feed page, the profile settings page, and of course the profile settings page allows you to change the picture. So here's the basic setup for that. We're just going to sign in, and then we're going to click all the links getting to the page where we're actually going to change this. And it's good to do that once. Don't do that if you have a whole bunch of different specs that are hitting that page. Or you can or not, depending on the performance. But hitting all of those screens, it's actually going to go and parse every one of those documents, and that can impact your performance. But like I said, it is good to do once, because you do want to verify the path to the page along with everything else. So there, of course, we're using attached file, using that profile image that's in the spec data we talked about earlier. Submitting the form, and then doing essentially the same thing. We're making sure the content has that success message, that the profile image was actually updated, and so we're checking the source of the image tag, and then browsing to the feed page and making sure that it's there as well. So now we're going to do some JavaScript, because sometimes there's instances where there's nothing to click. Like on the Twitter feed, if you hover over somebody's picture, then you get this nice little info box. So you can't really just click on that, and you can't tell the mouse to hover in an integration test. So wrote up this little story again. Hovering the profile picture displays additional information. It displays the name and follow status. And that test looks something like this. So we're going to generate a populated user, somebody who's got followers, followees, and tweets. We're going to generate an explicit followee called Hashrocketeer, and then we're going to make a tweet for that followee and tie it to the user with a follow. And then we're going to sign in as that user. Now that should take us straight to the home page. So once we get there, we're going to execute some JavaScript. And as you can see, there's some jQuery there. Under the covers, if you're using jQuery and you're doing a hover, then doing a mouse enter and a mouse leave is the way to do it. If you're using a different framework, of course, you would just trigger whatever JavaScript's necessary to get the thing to show up. So then you're just asserting that it shows the hover. So within class hovercard content, we're just looking for the words Hashrocketeer and ufollow, because those wouldn't be there if we were looking at the wrong person or or somebody you weren't following. And excuse me. So there's another way you can call it too. If you needed to assert against JavaScript, you can say evaluate script, and that'll actually return the value of the JavaScript. Most of the time, you shouldn't have to do that. There's some instances, like if you wanted to deal with OpenStreetMaps or OpenLayers or Google Maps or something, if you want to assert specific things with that, it can get a little hairy, and sometimes you have to run some JavaScript to get some assertions. External services are something we always have to deal with. We've got a ton of them, between payment gateways and Google Maps, and they really slow down your integration specs. We typically use a gem called ephemeral response, and it's really, really cool and easy to use. I like it because all you got to do is put this one file in your spec support directory, and it just kind of works. We're whitelisting localhost and 127.0.0.1 for Selenium, since it's hitting those. Setting a fixture directory, and essentially what it's going to do is when you run your suite, it's going to check any requests that go to external servers, and it's going to look for one that's already cached, and if it doesn't have one, it's going to go actually make that request, and then it's going to record the response and save it for however long you say the expiration is. So then subsequent runs of that test suite, they're just going to use the recorded responses, so you're not actually going to go out and hit those servers every time. So that can save you a lot of time. The response looks something like this. As you can see, it's just a dump of everything that went out and came back. Another problem we have commonly is dirty dates. We use something called timecop and travel to a specific date. Whenever you're dealing with stuff that is date dependent and you don't know what day it is, it makes everything a lot easier when you set the system time. There's always some gotchas along with this. One thing is before each and before all. Before each is easier to deal with, works better with let, but you can get significant performance gains by using before all. Now, doing that, the biggest thing to consider is how you're going to handle your database and cleaning it. If you're using Mongoid, it's really easy to clean your database. You can see right there in the bottom left. Active Record, we would typically use Database Cleaner and do something along those lines for cleaning it. Also, dynamically loaded elements. If you're using Ajax with Capybara, it's important to note that locate and have no XPath with a page should are going to wait for the element to appear. If you use page should not, then for whatever reason, it's not going to wait for the element. So you always want to say page should have no XPath or page should have XPath. Also, if you're waiting for elements to be there, you can just throw in a locate, and that'll tell Capybara to hang on for a couple seconds while it's waiting for something to get generated on the page. Another big one is false positives. As you can see, this page does not have a div with a class of map marker, and that wonderfully passes, and that's terrible. You don't want that. So the thing to do is what I call make a positively negative test, where we're asserting that within a map wrapper, we should have no div of map marker. So now you're going to get the failure, because obviously there's no map wrapper on the error screen. Another thing, if you have to deal with external servers, like a payment gateway, if you're using the rack test driver, it's not going to work. It'll only go against localhost. You got to switch to the Selenium driver, which is kind of a waste, but because now you're actually firing up a browser, and that's kind of a performance hit. But that'll allow you to go and hit those transparent redirects, things like that. And ephemeral response will record those as well. Also with random data, be careful, because if it's something that's going to go out over ephemeral response, then if the request is different, it's going to go and re-record it. So you need to be careful with the data that you're generating so that you don't run into errors like that. And the last thing was discovering dead code. Having a comprehensive integration test suite is cool because if you run that by itself with Archive, it's going to tell you one or two things. Either that you're not hitting that bit of code in your test suite, or that it's not actually being used. So if you're running Archive against the whole suite, maybe you got some model methods that have specs, so they're going to show up as being covered and they're being used when in fact they're not. So this is a good way to determine code that can be removed from your system. And that's all I got. Does anybody have any questions?
Is there a particular reason why you don't use WebRat? And would you recommend others not use WebRat, or is that just personal preference?
If WebRat meets your needs, then it's fine. We use it for a very long time. The reason we switched to Capybara was because of the very easy driver switching. Because you got a plethora of drivers available to you, and it's easy to add more. It's a really, really good framework.
One of the benefits of Cucumber is having your story right along with the steps that you use to test it. With RSpec, where do you keep your stories and acceptance criteria, like you showed on your slides?
Well, it's just made up of the describes, the context, and the if blocks. So you don't. Well, once you start filling in the test, then it gets more spread out. So you would really just see it in the output at that point.
Thanks.
Excuse me. So how fast does a typical suite run?
That depends. We use SpecJor on all of our projects. Our typical setup is we have a pairing station and then the 2 developer laptops alongside of it. The pairing stations are usually 8-core iMacs. So we'll run SpecJor on all 3 machines. And so you're distributing across, depending on the power of the developer laptops, 12 to 14 cores. And they run pretty quick. It's typical to have one that'll run like 2 to 5 minutes, something like that.
All right, I take back everything I said about integration tests.
But you got to be. It's easy to make them run long. Without SpecJor, we've had suites that take over an hour to run, and we do a lot of work, making sure that we get those to run in a reasonable amount of time. And we typically, let's say we have a 5-minute test suite. That gives you an opportunity to go and make those discrete commits if you're a little behind on that. So you can go and go detail through your commits for Git, and then while the suite's running, so you kind of make use of your time that way.
Cool. Thanks.
Over here. So the example you showed where you execute some jQuery from RSpec. So for that example group, you're using the Selenium driver, right?
That's correct.
Actually drive the browser.
Right.
Now, if you write some invalid jQuery or whatever, there's a bug in the JavaScript code you write. Are you going to see that in the browser? Like, is the browser going to halt and say like, hey, or it's going to be clear you did something wrong? Is it going to?
Well, if I had incorrectly hovered, then the thing wouldn't have shown up, and then when I'm interacting with it, it wouldn't be there. So it would have failed those examples. As far as whether or not a JavaScript error is going to halt, I believe that it will, but I'm not 100% sure. We can try it after the presentation.
Cool, thanks.
So I don't necessarily expect you to have an answer to this, but what happens if part of your application has a critical component that is a Flash component?
Flash?
Yes.
No. Steve Jobs said the Flash is dead. So.
Okay.
Any others?
Well, if you have additional questions or want to talk about testing, please come and see me. Also, I have a whole bunch of Hashrocket stickers. If you would like one, come see me and I'll give you one.
Okay.
Cool.
So thank you for Elliott.